Hi, Algebra 2 trig honors. We're going to pick up where we left off with these notes on polynomial functions. So just to remind you, for end behaviors, we had positive even, both point up, positive odd, the right arm points up, the left points down, negative even, both point down, and negative odd, the right arm points down, the left arm points up. Okay, so we were using our multiplicity to help us identify how to do this graph. So first, we count up the number of factors to find our degree. We have the first binomial squared, the second one is to the first, and the last one is to the third. So f of x is going to equal x to the sixth plus a bunch of other stuff. That gives us enough information to know that both arms point up. I know that my x-intercepts are at negative 4, 0, negative 1, 0, and 5, 0. The even multiplicity is going to be a bounce or a touchdown. The other ones are going to cross through. So when I graph it, I'll highlight it to make sure I don't forget that. So here's negative 4, negative 1, and 5. I know that I'm starting up here. I'm going to somehow get through this mess, and I'm going to end up in the upper right-hand corner, following the rules for those zeros. So as I come down, I have to bounce on my first point. That's my first turn. I'll need to turn around again and cross through on my second point. I'm going to cross my y-axis, and then I will cross through and turn around to come back up through my final point. So this one was the one where I bounced. All right, so this next one's working backwards. We're going to write an equation given this information. So I know that it needs to be degree 3. I want a negative leading coefficient, and I want these zeros. First, turn each zero into a factor. Okay, so f of x is going to be x plus 4, x plus 2, and x minus 3. If you have the right number of factors, I want it degree 3, I have 3 factors, I don't have to add anything extra. If I need more than that, I might have to create a multiplicity in order to accommodate my extra factors. We'll talk about that in the next problem. The last part is to have a negative coefficient. I'm going to need to pop a negative in there in the front. For the next one, similar, we've got an equation polynomial function of degree 7 with a positive leading coefficient and the following zeros. So we're going to set the f of x equal, leave a space in case we need a coefficient. My zeros are negative 3, so x plus 3, with a multiplicity of 2, so squared. Negative 1 doesn't have a multiplicity associated with it, so we just leave it to the first power. And 4, x minus 4, has a multiplicity of 3. And then our last one, a multiplicity of 1, and the factor is x minus 5. And then we should count up to make sure we have the proper number. So we have 2, 3, 4, 5, 6, 7. If I needed to, I would add in additional, but this matches all the multiplicities I was requested. So x plus 3 gave us negative 3 as the 0. X plus 1 gave us negative 1. X minus 4 gave us positive 4, and x minus 5 gave us positive 5.